Hello and welcome to another tutorial. We're going to continue our learning of Java using the ChatGPT AI. We've looked at how to install JDK, details of the primitive types supported in Java, and now let's look at the Java strings and important questions that we should ask an AI to help us understand the strings in Java are these ones. One is, what is a string literal? We saw that for primitives, we also have the concept of literals. Now for strings, we also have the concept of string literals. How does a string class work? Because a string is not really a primitive, right? It's backed by a class, a type in Java, which is a string. What is a string pool inside JVM? How to compare two strings? How to give a string representation of a class? Maybe these JVM details can go at the end, right? So we want to first understand the Java side, and then we want to also learn a little bit more about how JVM handles strings. There is, for example, another concept of what is a string deduplication inside JVM. This is a recent feature they added, deduplication. So we're going to explore these. So let's head to our ChatGPT session and start asking questions. So the first topic that we're going to ask is, what is a string literal in Java? And the AI tells us that in Java, a string literal is a sequence of characters. So it's a sequence of characters. And later, when we look at the source code of the a string class, we see that it actually implements a interface called char sequence. So a string literal is a sequence of characters enclosed in double quotes. So note that Java doesn't support single quotes for strings, right? Single quotes are used in Java exclusively for characters, one single character. Now in Python, for example, we know that both a single quote or double quote notation is used for strings, but in Java it's not allowed. Only double quotes are used for string literals. For example, hello world in double quote. You literally write this in your source code, and this will be interpreted as a string literal. Now again, string literals are not raw data types. These are backed by a string class. String literals are stored in the string pool, a special memory area in JVM where all string literals are stored. And we will look at why they decided to allocate a specific region of the Java heap or Java memory address for strings. Mainly because strings are immutable. So if you have multiple references to a same string, it's safe to assign them to only one object, because once you create a string, and you cannot change it. All string literals are stored. This means that if two variables contain the same string literal, they both reference the same memory location. Now you have to be very, very careful about this. And this goes back to our next question. What is the string class in Java? Now we know that one way to create variables of type string is to assign them to a string literal. And remember, string literals are stored in the string pool. But if you use the constructor of the string class, use the new operator, it forces the JVM to create different strings. A string class in Java is a built-in class. It's a built-in, but it's not a raw type. For example, an array, a primitive array, is really a raw type inside the JVM. Whereas a string class, it's a class. It has a class definition. In the Java standard library, it represents a sequence of characters and provides a wide range of methods to manipulate and format strings. The string class is immutable. You cannot change it, meaning that once a string object is created, its value cannot be changed. Now we have other classes that help you manipulate a string, called a string builder or a string usually the pattern is that you use a string buffer or a string builder to create a string, manipulate it, append more characters to the string, etc. But the string class by itself is immutable, and the main reason they made it immutable was for security reasons. String class provide many methods like length, char act, subsequence, index of. Unfortunately, Java doesn't support operator overloading. That's why, for example, a method like char add It's a very nice way, operator overloading for index operators for a square bracket. It's a very nice way of overloading this method. Unfortunately, Java doesn't support it. If you're familiar with C++ or Python, you know that they support this kind of overloading. So instead of calling a method, we call the operator. Substring, index of, last index of, starts with, ends with, to lowercase to uppercase, trim, replace, split, etc. And know that none of these actually internally changes the character sequence that forms the string. All of these, for example, substring or trim or replace, they create a new string and return a reference to it, to the user, right? So just remember that none of the methods have that are defined in a string class do any mutation to the content of that particular object. This class also overloads the plus operator, and this is very ironic things about operator overloading in Java, because even the people who developed the Java realize that not being able to use the plus operator for a string concatenation is very, very bad. That's why internally they overloaded the plus operator for a string concatenation. So that's one of the only examples or places where operator overloading was implemented just for the string class, because a string is an internal class. It comes with the JDK. And the plus plus operator for a string comparison, you have to be very, very careful about the plus plus. I will show you an examples. It is also commonly used in Java programs. So strings are the most basic and most important types, not only in Java, in any programming language. For example, for input output, if you want to read a text file, etc., it's all strings, right? String manipulation is very important. Obviously, in C++, they introduced std string, so they deprecated the use of raw strings, which was very, very error prone. Std string in C++, Java lang string in Java, and in Python we have the str class, a string class. All of these provide very convenient ways that you can manipulate strings, etc. So yeah, this is very important. And let's see what classes. So what classes or interfaces does the string class inherit from? So the string class in Java inherits from the following classes and interfaces. Object, every string is an object, so by default it has to inherit object like hash codes, etc., equals, etc. And again, a string is final, you cannot inherit from it, so you cannot change its hash code behavior, and that's very important for security reasons. They made the string class final. Serializable, every string has to be serializable, because a string actually internally it uses a byte array. I believe it used to be in the earlier versions of Java, a string used to use a char array. Each char is 2 bytes in Java, so it was not very memory efficient, and then switched to the backend of the string class is byte array. Comparable, so comparable is an interface for comparing to objects, so every string we have to be able to compare strings. Char sequence, this is an interface that just says that okay, this is a character sequence. Java IO serializable, and then Java lang comparable. Obviously these comparable and these are the same thing, right? So this is very interesting, and let's ask what is the internal representation of the string. So does a string class use a byte array or char array to store the strings? The string class in Java uses a char array to store characters of a string. Each element in char array represents a single character in the string. The string class stores strings internally as char array. This has the advantage of being more memory efficient, since each character takes 2 bytes of memory, while a byte takes only 1 byte. So I believe this is a mistake. It should be a byte array, not a char array. This means that when a string object is created, the JVM will allocate a char array with the same length as a string, and each element in the array will contain the corresponding character. Let's go back to our IDE and check this. So here I'm going to create a new class called strings in Java. Let's have a main method, and the first concept was a string literals, right? A string literals is when you create a type a string s1 and use a double code. hello world, right? All of these are characters, and then JVM backs this up internally in a class with a string object. So this is in fact an object. So you can say sysout s1 char at, right, at index 0, for example, and this will return is character h. Yes, however, you can actually directly work with this string literal, because again, to JVM this is an object, so I can just call char at on this string literal. So this could be a little bit bizarre at first, and the reason is that this is not the same behavior you see for primitive types, right? Again, string literals are not primitive types. What I mean is that you cannot say 5 dot something, right? 5 is not an object, it's not backed by any class, whereas this string literal is in fact backed by a class. So if you look at the basically what this means, that in the bytecode JVM represents, or the Java compiler represents this as the pointer or reference that's pointing to this. So I mean, to JVM internally, because this string literal is stored in the string pool, right? And this s1 is a pointer to that. And if I have another one, a string s2, the same thing, right? All of these are pointing to the same string literal. So if we compare the pointers using equality sign, double equals, remember, it doesn't call the equals method, it compares the pointers, and what happens, it returns true, because these two are pointing to the same object. That's because of the optimization that happens for string literals, and it's the same object, and then every time you assign this string literal to a variable, it returns the pointer to this. Now, as I mentioned, you have to be careful. If you force the string class with the constructor, the call to the new operator, it forces the JVM to create a new object, so s3 is not equal to s1 anymore. So now this this goes back to the concept of a string deduplication. If by default JVM allows that, then this also should return true. So let's look at what happens here. Now this returns false, which means a string deduplication kind of didn't happen, and this line, new string, forced the JVM to create a new object. So this object is the one that s3 is pointing to. It contains the same characters as this raw string or a string literal, but these are at different memory addresses, so we are consuming twice the memory. However, obviously, if we say s3 equals to s1, this should return true, because equals looks at the contents, right? And another thing that we just asked ChatGPT was whether the string uses a char array or byte array as a backend implementation. And if we look at this, we also saw that a string implements the serializable, comparable, char sequence, constable, and constant description. So looks like these are the new ones, right? I'm using JDK 19. So constable is just describe constable. This is something new which returns optional, and const description is reflective. It just returns resolve constant disk. Again, these are something that have been added recently. So as you can see, it actually uses a byte array, not a char array. I believe it used to, at least in the older versions of the JDK, it used to use a char array. Let's see if we can actually switch to an older version of the JDK. Alternative JREs, let's switch to, for example, JDK Java SE8 and see what happens. A string. So as you can see, in the JDK 8 we were implementing serializable, comparable, and char sequence. It doesn't have constable or const disk. That's the first difference between JDK 8 and JDK 19. And also you see that now it's using a char array instead of byte array. And remember, chars in Java occupy 2 bytes instead of 1 byte. Now, obviously 2 bytes allows UTF-16 or extended UTF-8. Now, the reason byte array is more efficient is if you're using English, anything that's compatible with ASCII, JVM automatically realizes that only allocates or uses 1 byte in that byte array. In the, for example, JDK 19, it doesn't have to use 2 bytes. So if you use a character that requires more than 1 byte, JVM then uses 2 bytes of that byte array. And again, so in JDK 8, let me copy and paste this. So we see that in JDK 8, we have this as the backend implementation, private final char array value. In JDK 19, let's switch back to our JDK 19 and open up our string class. Now we have these two constable and constdisk interfaces, and we have private final byte array. So it's not a char array, it's a byte array. So it's more memory efficient. So more memory efficient, especially for ASCII, for example, English characters, ASCII, anything that's compatible with ASCII. You don't need to consume 1 character or 2 bytes. You can just use 1 byte, right? So this is one of the important things to note. And I'm curious to see when this change happens. So let's go back to, let's say JDK 16. Let's see what we have in JDK 16. So we have the byte array. So JDK 16 was already implementing this, but does it have those 2 additional? Yeah, it does have those 2 additional interfaces. What about JDK 11? Let's look at our string class. JDK 11 doesn't have those 2 additional strings, but it uses byte array. So it looks like after JDK 8, from JDK 9, from JDK 11, we definitely switched to byte array for better memory efficiency. So I'm going to switch back to our JDK 19. And then, so as you can see, we said that if you force the new or the constructor of the string, then you're creating a new object, allocating new memory. What about value of method? So a string s4 is a string dot value of. Let's see, does it accept a string? So value of is basically basically a static factory method, right? So you want to go value of and say hello world, right? And the reason this works is that because here char array, this accepts an object and then it calls the char array. Let me just so sysout s4 equals s1. Let's see what happens here. And now we're getting so let's comment this out. So as you can see, when we force the constructor, s3 equals s1 returns false. So we definitely allocated new memory. Whereas when we use this static factory method, value of, it actually didn't do this. And I believe what happens behind the scenes, if we go here, is that it calls the object to a string. It's very interesting because the object that we're passing is a string literal, and the representation of the string literal is itself. So if you go back to a string to a string, obviously this is in the object class. So if we go to our a string class and look at the toString method, it returns this. So it returns a reference, right? It doesn't create a new object, it returns a reference. Usually you create a string and then return the reference, but for a string class itself, it returns a this, just a pointer to itself. So what happens here is that in fact we are returning, this is a string literal which is backed by a string class, and it returns a pointer to this, and any string literal will be in the string pool. So when we write these string literals in our source code many times, we're not creating new objects. So it's very interesting to understand this. So one string literal here, one string literal here, 2, 3, 4, 5. We're not creating 5 different objects. Remember, even if you're executing this code, new string, calling the constructor, first this temporary object has to be created, and then a pointer to it has to be returned, and that pointer is passed to the constructor and it returns a pointer to that newly object, right? Just be careful how this works, the new calling the constructor versus passing this temporary to the constructor of the string object. So this is one of the things that makes a string literals efficient, because we're not creating different objects each time we write the same string literal, right? Now this value of, that's why this value of is very powerful, in the sense that if you're constructing a string using this static factory method, then it still works with string literals. Now you probably can guess that behind the scenes what's happening here. Most likely we're just returning a reference to this string literal. So we can actually go and look at the bytecode, open with the class file viewer, and I'm going to put this side by side. We are at line 15, and we can actually, let's comment everything out to just focus on this line of bytecode. And note what happens in the main method. Load constant a string hello world. So it says, okay, this hello world is in a string pool, just load it, put it in the string pool, and invoke a static value of. We're passing the object and then we're returning a string. And what happens here is that this object is a string literal, and we saw that this will return a reference to itself, to the string literal. Therefore, S for this line is completely equivalent to saying that a string S5 equals hello world, right? These two are, or we can use the line first line here. These two should be completely equal. So and you see one thing that happens is that we have this call to the static, so a little bit less efficient, maybe makes the code more readable, but always for the string literals, always just directly assign them to a string variable. Now there is one concept that it's good for everyone to know when they're dealing with a string in Java, and is the concept of a string interning. So we force the constructor of the string, and then we compare this with the original object. We saw that S1 and S3 are pointing to different objects, even though they're supposed to be the same string literal, or contents are the same. And then one thing that you can do is say that S3 or maybe we can put it here, the concept of interning, S3 dot intern. What this does is it tries to, if this is backed by a string literal, it tries to put it in the string pool, and if this object is already there, then it just points to that object. So I believe when we run this, now we're still getting false. So intern returns a string. Again, intern doesn't manipulate anything, so we can say S3 equals S3 dot intern. Now we're getting true. So what happens is that when we say intern and it tries to, JVM looks inside the Java heap in the string pool to see if there is a raw string, there is a string there that corresponds to the value of this object S3. If yes, it returns a reference to that object. Now here we're not doing anything. This is mainly if, let's say, you're reading a very long file, text file, and you want to make sure that you put everything in the string literal, for example, a string pool, for example. So you can use this to save some memory. This is really not necessary. We're not gaining much because when we assign this to S3, now the original S3 that was pointing to that object becomes a dangling pointer, and it's eligible for garbage collection. But string interning is something that you should be aware of. So I hope you enjoyed this lecture. In the next one, we will continue with our discussion on the strings, which is a very important topic in Java programming language. So please stay tuned, and I'll see you in the next one.